Alright, so this is going to be the video for lessons 2.4 and 2.5. They're dealing with inequalities, so it's a review, but it still will probably be a little lengthy video just because we're doing two lessons. But I want to try to go through this very quickly. So first of all, pay attention to these symbols with words, okay, especially if you can't remember them. It's a good reference page to go to. Also, make sure if you need to look at examples here, how they've done some of the problems, and especially the word problems, it might give you some help. Okay, we're going to go straight to the evaluate section. So here, I'm going to start with number 3. It says write an inequality that represents the description and then solve it. Okay, so for this particular one in number 3, it says twice a number x, so 2 times x is less than, so is less than 10. So there's our inequality. Then we solve, so we divide by 2, and that gives us x is less than 5. Okay, what about a word problem? Let's go to number 5 here. Dave has $15 to spend on an $8 book and 2 birthday cards C for his friends. How much can he spend on each card if he buys the same card for each friend? So that's important. So in other words, I'm going to spend $8 plus 2 times C, the 2 cards, and I have $15 to spend. Therefore, it must be less than or equal to 15. I can't be more than 15, but I can be equal to 15 since I have $15 to spend. Now we solve. So we subtract 8 from both sides. We get 2c is less than or equal to, and that is 7. Then we divide by 2. So c is less than or equal to 350. Make that decimal a little bigger. Now, remember, this is in the context of the cost of a card, so that means the card could be $3.50 or something less than that. All right, let's go to the page. We're going to look at problem number 9 here. It says to solve. Okay, so a couple ways you can do this. You can go ahead and do distributive, and that's probably the easiest thing. We always talk about simplify before you solve. So first thing I'm going to do, I'm going to go ahead and do distributive property. That's going to be 3 plus 3 halves minus 1/2 x is less than negative 7. Combine your like terms, so 3 plus 3 halves will give me 4.5, but if you want to do it as an improper fraction, it's up to you. So however you want to do this, you can use the calculator obviously to do this, but if you do 4.5, that would be 9 halves minus 1/2 x is less than negative 7. So then we get rid of the 9 halves by subtracting from both sides. And if I do that, so those cancel, so I have negative 1/2 x is less than negative 23 halves, I believe is correct. Then I have to get rid of the negative 1/2. So how do I do that? Well, you can divide by negative 1/2, or I told you guys when I solve, I multiply by the reciprocal, which is 2 over negative 1. Now, this brings us back to one of the things we learned, which is whenever you multiply or divide by a negative number, you always have to flip that inequality symbol. So as I come down, I'm going to draw an arrow on my inequality symbol and make sure that you realize you have to flip it because I'm multiplying by negative. So the negative 1's cancel, the 2's cancel here, so that leaves x is greater than, right here the 2's cancel, a negative divided by negative would be a positive, and that would be a positive 23. So x is greater than 23. So remember our rule, multiply or divide by negative, flip your inequality symbol. Okay, let's go on down to problem number 19. Okay, looks pretty complex, a lot of steps here, but again, it's just solving an equation is all it is. So the first thing we do, again, I'm going to do distributive here and do distributive here on this side. So if I do that, then I get 2x minus 24 plus 24 is less than 4x plus 20. Right here, those 24s are going to cancel. So I get 2x is less than 4x plus 20. I'm going to subtract 4x from both sides. So I get my variable on one side. So that's going to give me negative 2x is less than 20. Then to get rid of the negative 2, I divide by negative 2. Again, I'm dividing by a negative. So since I'm dividing by a negative, remember, got to flip my inequality symbol. So that's going to give me x is greater than negative 10. Alright, let's go to the next page. Look at problem number 21 here. It says a crane cable can support a maximum load of 15,000 kilograms. If a bucket has a mass of 2,000 kilograms and gravel has a mass of 1,500 kilograms for every cubic meter, how many cubic meters of gravel, G, can be safely lifted by the crane? Okay, so what do we have? We have a bucket, which is 2,000 kilograms, plus 1,500 kilograms times G, because it's 1,500 kilograms for each cubic meter, and the number of cubic meters is G here, it tells us. Now, it says a crane cable can support a maximum load of 15,000. So that means this together has to be less than or equal to 15,000. So that's the most it can hold. Alright, so now we're going to solve. So again, we just do like normal, solving an equation. Subtract 2,000 from both sides. Subtract 2,000. So 1,500 G is less than or equal to 13,000. Then I'm going to divide by 1,500. 1,500. So if I do that on the calculator, do that real quick. So you get 13,000 divided by 1,500, and that is 8.6 repeating. Oops, not very good. 8.6 repeating. So it says how many cubic meters of gravel can be safely lifted by the crane? 8.6 cubic meters, so that would be m to the third power, and we'll talk about that later, but that's our value, that it can be less than or equal to that. That's the max. Alright, we're going to do one more in this lesson. We're going to do problem number 23. This is one of those error problems. So it says Finn is trying to find the maximum amount of time he can practice the 5 scales of piano music he's supposed to be working on. He has 60 minutes to practice piano and would like to spend at least 35 minutes playing songs instead of practicing scales. So he says T is the number of minutes he spends on each scale. Remember, he has 5 scales. So this is the inequality he set up. Here's the problem with this. He has set it less than or equal to 35. Well, remember, 60 is the total amount of time he has to practice. So he wants at least 35 minutes of playing songs plus 5T, 5 scales at T minutes per scale, and all of that together has to be less than or equal to 60. That's what our inequality should be. Well, if we solve it like this, subtract 35, then I'm going to come below here. 5T is less than or equal to 25. Then we divide both sides by 5. And we get T is less than or equal to 5. So what that means is he really should be spending 5 minutes or less on each scale in order to stay within the time frame. So I'm going to take just a second here to pause, allow you the opportunity to flip to lesson 2.5 now, and then we'll do the notes there. Okay, so in lesson 2.5, we're doing compound inequalities. That means we're doing two at a time. So there are some different things within the context of this lesson. There are these truth-false tables. We're going to skip that. Okay. Here is something I want to point out to you. For a graph using the word and, okay, you notice the graph comes together. Okay, that's going to be real important. Okay, you can look at how the book explains it here. Whereas an or, the or graphs go apart. Now we've done the open circle, closed circle thing before, so we're going to look at that and continue on. So here's some good examples to look at as well. And again, we're going to go straight to homework section. Alright, so we're going to start with problem 7. We're going to skip the truth tables there. Come to problem 7. Here's an or. Now remember, when we were looking at ors should go apart. Okay? And the reason they go apart because it's one or the other. So we just work out each inequality. So here I'm going to subtract 3. So we get 4x is less than negative 8. Divide by 4. Divide by 4. So we get x is less than negative 2. Or, now I do the other one. So I'm going to write it out up here. 4x plus 3 is greater than 23. Oops. So subtract 3. 4x is greater than 20. Divide by 4. So x is greater than 5. Okay, now I graph each one. I go to negative 2. I put an open circle because there's no equal sign here. And it says x is less than. Since my variable's on the left, this is pointing to the left, so I shade to the left. Put an arrow. Then I do the blue one. I go to 5. Again, put an open circle because there is no equal sign here. And then my variable's on the left, it points to the right, so I shade to the right. So I shade to the right and put an arrow on it. Now again, or should go apart. Alright, now let's look at problem number 9. 9 is an and problem. They don't use the word and. They just put it all together because it's this and this. It's two things together here. So what I'm going to do is I'm actually going to split it up using the word and. I think this makes things a lot easier for you. So in red, I'm going to do the left-hand side. Negative 6 is less than x minus 12 over 4. And now I'm going to write the right-hand side. Now, the way I do that is basically I cover up all of this, and then I'll just take the middle part and the inequality symbol here. So I have x minus 12 over 4 is less than negative 2. Now I solve each one of them independently. So I take the first one, and to get rid of the 4, I'm going to multiply both sides by 4 since I'm dividing here, so those cancel. So that gives me negative 24 is less than x minus 12. Then I'm going to add 12 to both sides, and then I get negative 12 is less than x. Okay, then I'm going to work the right hand side over here. So the steps are similar. I'm going to multiply by 4, but you're going to see I'm going to get different values because I have a different number on the right. It's less than negative 8. Then I add 12 and 12. So then x is less than 4. So I have this word and here in between. Now what I'm going to do is I'm going to take the variable here and I'm going to put it once right in the middle. And then I'm going to put my inequality symbols. X is less than 4. X is greater than negative 12. So here it reflects what an and should do, which is come together. So I come up here to my graph, put an open circle at negative 12, open circle at 4, and x are the values in between them. Okay, let's go to the next page, look at number 13. So here it wants us to write an inequality representing it. So here's where we want to remember. These go apart. What goes apart? An or goes apart, okay? So what do we say? X is what? less than 9. Okay, why less than? Because it's going to the left, and here our inequality symbol is pointing to the left. No equal sign because this is an open circle. Then I write my second one, or x is greater than, because it's shaded to the right, 11, again, open circle, so no equal to. What about one that comes together, like 15? 15 is an and, okay? It's an and. Now you can write the word and, or just put x in the middle, put what it's between. Now I do those inequality symbols, and x is between 2 and 10. All you need to remember is, if they're open circles, then right here there is no equal sign under it. Okay, another way you could write it, if you chose to, you could say x is greater than 2 and x is less than 10, because you're shading to the right of 2 and to the left of 10, and there's the word and. Personally, though, I prefer putting it all together here when you're writing your inequality. Okay. Problem 17, a word problem. And these are actually really easy. Okay, it says write a compound inequality to show what's being represented here and then graph it. So it says that the environment, the temperature in the cage should be between 70 degrees and 95 degrees inclusive. That's important. So what's that mean? That means when I write my inequality, whatever variable you're going to use, I'll use T here since it's temperature. Temperature, since it's inclusive, is less than or equal to 95 and greater than or equal to 70. Which means on the graph, when I go to 70, I put a closed circle. When I go to 95, I also put a closed circle. And then what do? I shade in between them. So inclusive means you're including those values and it's in between them. Alright, one last one. We are going to do problem number 23. And I'm going to show you how to do this one without doing any work whatsoever. And the way I'm going to do that is by looking at the graph answers and my symbols. Okay, in other words, this is an and problem, which means graphically what should happen? They should come together, which means it's either this one or this one. The next thing I do is I look at my inequality symbols. There is no equal sign here, which means what? They should be open circles, which immediately tells me it's that one. So this one right here is A. Okay. B right here is also an and problem, but you see it has the equal sign. Therefore, they're closed circles, which means it's got to be this one. So I'm not doing any work at all. I'm just looking at basic concepts to help me pick them out. Okay, the next one. It's an or. Ors go apart. Look at my symbols. No equal sign, open circles. Therefore, it's this one. So that one's C, which by default makes this one D. But again, you can look. Ors go apart. Equal sign, therefore they're closed circles. So look for shortcuts like that and being able to do a problem. So these are the notes for 2.4 and 2.5 together.